In this video, we're going to use our knowledge of properties to help simplify algebraic expressions, okay? So we're going to use both our knowledge of simplifying expressions and also the properties, okay? What I'm going to do is, it will generally give me a box like this, and I'm going to have the math worked out, and I have to say what the person is doing. So I'm going to look at my first box, and I pay attention to that. It says -4, parentheses, -2x plus 5, parentheses, plus 2, parentheses, 0.5x plus 2, parentheses. And the justification is given because if I look in my original equation, that is the exact same thing. So that is just given to me. But then I compare this line to this line. How did I get from -4 times an algebraic little expression right there to 8x? So I'm trying to figure out how I came up with this 8x. Something definitely changed. So I know that -4, if I was trying to simplify this up here, I would distribute it. That's what I would do, right? And -4 times a -2 makes a positive 8x. So my guess is that they use the distributive property of multiplication. So my answer would say is that they use the distributive property. And if I check all of them, -4 times a positive 5 is -20. 2 times 0.5x would just give me x. And 2 times a positive 2 would give me 4. So that is what I did. I just distributed. Okay? Now I'm looking at the next one. I have 8x to start, both of them. Good, so those match. But I had -20, and next I have x. So I'm going to compare the entire thing. So up here I had -20. I still have -20, it's just in a different spot. Then I had an x got moved. And last but not least, I had a 4 that stayed the same. So all it looks like is I have my same numbers, they just got moved around. And the property that tells me I can swap numbers is the commutative property. So I'm going to write commutative property. All right. And on the last one, I have a 9x. How did I get from 8x plus x to 9x? Well, I just combined my like terms, right? I simplified. So my justification would be combine like terms. Because 8x plus x is 9x, and -20 plus 4 would be a -16. Then it says, are they equivalent? It's asking, is this final row right here equivalent to what it's equal to up there? 9x minus 16, 9x minus 16? Yes, those would be equivalent. Okay? So all I'm doing is justifying the math that the person shows, okay? All right, if I flip it over, back here I have a different type of problem. It gives me what I'm supposed to do, and I have to simplify it. So the first one tells me that it's given. If it's given, I know it's supposed to match my original exactly. So I would write 12x plus 7 over 4, subtract 30 minus 18x over 6. That matches it exactly. Now it says convert to addition. So I'm going to take all my subtraction signs and convert it, okay? So I copy down, oh, and use the distributive property, division over addition. Okay, so I'm going to break apart. So my distributive property tells me I can take my numerator and break it in two. So I'm going to start there. So I'm going to write 12x over 4, keep my sign, plus 7 over 4. Here's a negative, so I'm going to change it to plus a negative. 30 over 6, another subtraction sign, I'm going to change it to plus a negative. 18x over 6. So I did two things. I changed all my negatives, or my subtraction signs, to plus a negative. And then I also used the distributive property of division. But because this negative is being applied to this whole thing, that would actually change my last sign as well. So that would become positive. Okay, then it just says divide. So what is 12 divided by 4? 3, keep my variable. 7 divided by 4, I don't know, so I'm going to leave it as plus 7 over 4. I'm not sure on that one. 30 divided by 6, I know is 5, so it's plus a negative 5. And 18 over 6 would just give me plus 3x. Then it says use the commutative property, so put my like terms together. So I start with a 3x. I have another 3x over here. I bring the sign to the left of it. And then I have plus 7 over 4, subtract 5. Then it says do the addition of like terms. So 3x plus 3x is 6x. And 7 over 4 minus 5, I don't know, so I'm going to quickly convert it to 7 over 4 minus 20 over 4. So that would give me negative 13 over 4 minus 13 over 4. It says, are they equivalent? Is this the exact same as that up there? No. So these ones are not equivalent. Okay, I cannot simplify this side and get that answer. That is not true. So that's just a quick 2 on how to do it. I will show you guys one more, this bottom one, because I like this one. So if I look, or not that one, sorry, this one right here. Again, this kind of has a lot. So the first thing I'm going to compare is I'm going to look at my original equation it gives me and compare it to the original. If they are the exact same, my justification is that it's given to me. Okay, so that one was given to me, luckily. All right, now I'm looking at the next one. I have 5 over 6x, and up here I had 5x minus 4 over 6. If I were to simplify this, I would use the distributive property of division because I would want to break apart that fraction. So that is what I'm assuming they did. They used the distributive property. And I will check it in just a second. Distributive property. Okay, so 5x over 6, keep my sign, minus 4 over 6, correct? And I would just copy down the other two. So that is what happened. All right, if I look at the next line, I want to see what happened. They changed this from a subtraction sign to plus a negative. And they also changed this number. What did they do? They went from 2x to 12 over 6. They wanted to get a common denominator. Do you see how 6's are on the bottom of all of these? So they, oh, sorry, let me move this so you guys can see it better. So they got a common denominator. And they also changed it to an addition problem. So I'm just going to put change to a plus sign, change to add. All right, so now I'm looking at the next one. I still have my 5x to begin with, right? 5x, 5x. But right here I have plus 12 over 6x, and that was over here in the last one. So again, I'm seeing the same numbers, but they're in a different order. When I see that, I know that I use the commutative property. The commutative property tells me I can swap numbers. Or swap the order of the numbers, I should say. So that's how I know they did that. And then down here they made it even smaller, and it looks like they took 12 plus 5, and they got 17 over 6x. So I'm assuming that they combined like terms. All right, and I want to know, are they equivalent? I'm paying attention to my last box right here and up here. Are those the exact same thing? Yes. So I could simplify this equation or expression and get this expression, okay? And that is how we simplify algebraic expressions when it gives us, when we're trying to use a justification. So.